forgot yesterday. All right, so let's hit the warm-ups. They get progressively a little bit more complicated. So we're on number 11 in here. Right here, can you see it? No, just kidding. A second, I'll blow it up. That was 10 from yesterday on USUP. Here's number 11. All right, so it gives you the graph of F. It says it's got a line segment and a semicircle, and then it says to find the value of that, right? So when it says to find that value, what should your brain think you're going to be finding? In just a word. Area. Thank you, Sam. Yeah, so this is a question about area of the stuff underneath that curve and above the x-axis. You're going to have to split it because the shapes are different. So go ahead and kind of take a look at that. And so I've got an obvious triangle over here that's 2 by 2, right? So I do half of the base times the height. It's above. That's just 2. But then over here, I've got a bit of an issue because I can't tackle that curvature straightforward with geometry. So you have to think, well, that's got to be able to be done geometrically because I don't have a calculator, right? And I don't know what the function is. So, Annika, how are you going to think of that stuff in here so that you can figure out what the shape area of this weird stuff is?
I would like find the area of the rectangle and subtract the area.
Exactly. Just take the area of the rectangle. That we know how to do. So let's do that. It's a 2 by 2, correct? So it's 4. 2 across, 2 up. And subtract the, what did you say, Annika? The area of that semicircle. So how do we get the area of a circle? Go ahead, Annika, keep going.
1/2 pi r squared.
So she's going to do 1/2 pi. The radius of the circle would be 1, right? So r squared. Are we good with that? But we also had the 2 over here. So we've got 2 plus that. So it looks like I'm at 6 minus pi halves. That would have been an A. What do you think about that one, Kalia? Would you have been able to tackle that one? Yes? All right. There's some that get tricky. I mean, so far this one's not too bad. So let's go to number 12. How about Priestley? You're up. You ready? Particle motion. We're moving so that it's acceleration. So I'm going to write that down. So go ahead and write down A of t. You don't have to write the full problems. This is attached. So if you want to see the full problems, you can do that at another time. So Priestley, I'm given the acceleration. And now I'm going to go kind of ignore the next sentence because I'm going to say, well, what are they wanting me to find? Position. So you have to ask yourself, how do we go from acceleration to position?
Integrate.
We need to integrate. How many times?
Twice.
Twice. Yep. So we're going to integrate once, integrate twice. Good, right? So why did they tell me this stuff, Priestley?
So we can find C.
Yes, to find the C's as we integrate. Excellent, you guys. I was kind of thinking, the reason I usually talk through the first one is a lot of people are like, I forgot it all. It's like, it's okay. That's why we're doing it. Because I assume you forgot most of it. But we've been doing great. So, all right, so let's integrate that once. To get our velocity, we'd have 4t squared over 2, which is 2t squared, plus, you're right, Priestley, my constant. It's usually really easy to find that constant when you don't have a calculator because that's not the point. So they tell you at 0, that has to spit out an 8. So basically, they're handing you, Carl, the constant. So that's got to be an 8. What did you say to do next, Priestley?
Integrate again.
Integrate again. I have to go back to position, whether you like to call it x or s, I don't care, but it'd be 2t cubed over 3 plus 8t plus another constant. Read the problem. What's the other constant? When I put in a 0, what's got to come out for the position? I'll just stick with you and then I won't go. 5. Yeah, so my other constant's 5. Perfect. Excellent. And now it says to find the position at time 3. So again, no calculator. You have to go plug in that 3. It'd be 2 times 3 cubed over 3 plus 8 times 3 plus 5. A 3 would cancel. So it'd be 2 times 9. I'm seeing 42 plus 5, 47, right? We're done. What'd you think of that one, Harper? Would you have done it, you think? You just think it out, and I would attack each one. Like when I asked him, I said, well, what are you given? How do you get there? Integrate twice. Excellent. All right, let's go see what our next one entails. Except I think I needed to scroll down. All right, number 13. Go ahead and read it. Y equals, and I'd write that down. Y equals sine x minus 1 over x. And Mallory, what are they asking me to find? The what? Almost. Oh, the derivative twice. Is that what you said? Okay, I thought you said of y. Yeah, I have to derive it twice. The easiest thing to do is just write this sucker down. Right? Saint cloud, negative saint, negative cloud. It ends the way it begins. Once, twice, out, out. That was easy, right? And then I pretty much know which one it is if I derive it twice, right? But let's go do it. We have x to the negative first. First derivative would be negative 1, x to the negative 2. Second derivative would be 2, x to the negative 3. D falls out. Now that one was easy. Don't you think, Max? Like that one, you should be going off. Yeah. No problem on 13. Let's see what 14 has for us to do here. All right, I'll read it for you. This is the graph of f prime. I always like to bold that. It's got 2 line segments. If f of 1 equals 2. Now, whenever they talk about f prime and f, think the rate that it's snowing and the amount of snow. I think that's the easiest thing to do. So that graph up there is giving you the rate at which it's snowing. The area under the curve represents snow accumulated. So right here, accumulated 1/2 of an inch of snow. What happened over here? Melted. Yep. And then more snow. And what does this mean? It means before we, at 1, we were already at 2 inches of snow. Does that make sense? So if at 1, I'm already at 2 inches of snow, after gaining 1/2 an inch, it means at 0, I must have had 1.5 inches before this even started. Then I gained 1/2 an inch, right? And does that make sense? I think the snowfall really helps sort out the f prime f issue. If it doesn't help for you, that's fine. But it says for how many values from 0 to 6 will we have 1 inch of snow? So think about that. There's 1.5 inches, I gained 1/2, right? Then I lost a bunch. Do you think I'll pass through 1 on my way? Definitely. Let's see how much we lost though. It's what is that? A 3 by 2, 6, going down 3 inches from 2. So definitely, right? Pass through 1. And then over here, I was just making sure I didn't leave the domain, which I didn't. I said 0 to 6. Over here, I have a 2 by 4. Half of that gained 4 inches. So how many times will I pass through 1 inch? Twice. That's a really hard question unless you put it in a different context. What do you think? We good with that one, Kaden? All right. You guys are really listening with these. They're helpful. I know it's kind of boring when I do the whole first one with you, but they are helpful, so just trust me. All right, next one. From way back when, this is from our first chapter. Find the value of k that will make the function continuous. Harrison, would that question stress you out? Not really, right? To be continuous, what has to happen for a piecewise function? I'll move up here because I have my mask on. I'm getting a little claustrophobic. So Harrison, what has to happen for continuity of a piecewise function? They have to equal each other. They have to meet up at those y values. All right, so we just have to force 3 plus k times 1 to be equal to 4 plus e to the 1 minus 1. We'll have to force them to meet up so we don't have a gap in the graph, basically. So 3 plus k has to equal 4 plus e to the 0 has to equal 5. I think a lot of you in here could have at least 13 of these first 15 correct. I don't think we've had any super curveballs. What do you think, 40? It's been, so far, I'm not stressed out about it. I hope you aren't. Slope field. I'm going to let you actually, because this one is this chapter, I'm going to let you guys raise your hand when you know it or you're stuck. Which of the following could be the solution for the slope field? You should be doing exactly what Bryce is doing. I don't know if he's doing it on purpose. This is where I said to squint, and what you see is the solution. I don't know if you're doing that on purpose or not, right? So you're going to ask yourself, when I squint, do I see the sine wave? No. When I squint, do I see a parabola opening up? No. When I squint, do I see the exponential growth function e to the x? Yes. When I squint, do I see natural log? It's basically the known parent functions, right? What's the answer to this one? C. Okay. No work to show, so I don't quite know what to do with that. All right, a few more here. 17 down below. Here's 17. This is also this chapter. This is our 7.1 from last Friday. This throws kids for a loop sometimes because you have to work from the answers forward. So I'm going to let, again, because this one's this chapter, it says that is a solution to which one? You really just have to start. When I take its second derivative and subtract twice its first derivative and then 7, do I get a 0? The answer is no, you tried. It's frustrating because it shouldn't be a multiple choice question, but that's the only way you can approach it. So you go try. That was from our 7.1 from Friday's notes. You took them from AP Classroom. You might say, I thought to find a solution, we separate variables and stuff. You can't because of the second derivative down here. So it's basically you just knowing plug and chug. I don't know the answer because you're my first class. But I will put one like this on your test next week for this chapter. And one like that slope field one. So that's why I'm going to make sure you do this one on your own. Don't forget the derivative of e to the u is e to the u d. BC hates these, but I always tell them, you know what, it's probably A or B. Because they're not going to have it be D because that would take so much time. And I haven't done this one, but I'm guessing it's A or B. So that makes, is it A? Is B? We get it B to work. So you have to, you're telling me guys at home that it's B. And if just in case you do the first derivative is this. And then the second derivative is e to the 2x times 4. And so those are what you would be, oh, I circled C. It's B. So then you plug them in and you guys are telling me that gives you a 0. Correct? All right, no more need to discuss that one. Moving along. They take a while. This one I expect most of you to forget. It's a very obscure derivative. The derivative of arctan. Who's got a rock solid memory? Do you remember? The derivative of arctan. I told you we needed to remember arcsine and arctan's derivative. Those are the only ones that get asked. Let's see if you remember. This is just a pure memory question. And it'll be in your memory once you take the AP test because we'll be doing it regularly. But anyone remember from way back in chapter 3 what the derivative of arctan is? What'd you say? You can try it. I won't hurt you. What'd you think it was, Priestley?
Like something over the square root of 1 minus 1.
Oh, so close. That's arcsine. Tan's the pretty one. We feel prettier when we have a tan, so get rid of the root and the subtraction and you got it. What did you say?
U prime over 1 plus u squared.
Yes. Where u is the argument in here. So on this one, they did keep it just like a nice x. So the derivative of x is 1, right? So u prime over 1 plus u squared. And now you just plug a 1 in. So once he remembers that, that's a super easy question, but our memories usually forget that one. We'll come back. We'll come back to it. several times. So arc sine, but since we're on that topic, arc sines is almost the same. It's u prime over, remember I told you it was uglier for two reasons. One of them's the root, yep, so it's the square root of, and what was the other reason? It's the uglier operator. All right, so that's just purely memorizing, Clayton. I would expect most of you to get that one wrong. This is one of the most missed types on the whole AP exam. We're almost done. It's our. I think I'll quit here at 19. I want to get that FRQ in. I don't want to leave. I want to leave you with just one. Hopefully, when you leave here. What is this testing? One of two things. So let's go do what LaRuda always says. Plug the 0 in and see what we get. 0 over 0. We do not circle D. We do not circle A. Right? 0 over 0 is an indeterminate form. We have two ways of tackling this. What's one of them? L'Hopital's rule will do it. So pretend the h is an x. It also could be done with the formal definition of the derivative, but most kids don't recognize that, Sam. They'll do a L'Hopital on it. So I think I'll stick with L'Hopital then since you said it. But remember, pretend that this is an x because you're not used to taking derivatives with respect to h. When I take this derivative, what would I do? Go ahead, Sam. You told me to L'Hopital. I'd have to do the derivative of the top over the derivative of the bottom. The derivative of the bottom is 1. So I just need the derivative of the top.
24.
Yep.
1/2 plus x squared.
Yep.
And then plus 1 times 1.
Times 1. So I'm just going to leave that. Right? And then the derivative of the constant is 0. So once you L'Hopital it, again, it'd be over 1. Remember, L'Hopital's the derivative of the top over the bottom. Good job remembering that, by the way. Now just plug 0 in. Should be 24 times a fourth, right? 40? What's the answer? 6. I didn't expect anyone to remember L'Hopital. You guys are very much impressing me. Digging that. All right, that's not the same people answering all the time, which I'm really digging. You're giving me good vibes with this review. Sometimes I'm like, oh no. But it always comes together by May, but usually doesn't come together in March. What have you guys been doing? Mathness? COVID? Injections that have math? Enzymes in them? Or what's going on? This doesn't go this way usually. All right, we're done. So I'll video from 20 on out to the end. It'll be super boring tomorrow. You're just going to be listening to me talk. Just get a snack, have your brain on, and just chill. Okay? Should be stressful, right? But very boring. All right, what's next? We have 3 FRQs, one together. The other one I'm hoping you do maybe with a partner before you leave if we have time, with a half an hour. So I think we should be able to do one together, one on your own, and one for homework. The potato is going to be done together. If you Google 2017 AP Calculus potato memes, it blew up on Twitter. It was hilarious. Try it. There's some very funny. Kids did not like the potato problem, and they had no problem posting about it, even though you're not supposed to. What'd you say?
But you know, disclosures probably got broken on that one.
Yes, exactly. Like they weren't supposed to post anything. I think I opened the tweets though. I want to read a couple of them because they are kind of funny. Well, there's also a question about bananas. So they had a banana right in, right out, and then they had a potato. And so when you need to solve for the temperature of the potato, but you're already going to college. What's this next? I don't know. There's some funny ones. So there's always 4% of you that'll take a different form. I don't know the purpose really, but it says when all the funny tweets are about the potato question and you can't relate because you had the yeast question. When everyone is talking about the potato question and you don't remember there being a potato question. And then, I don't know. Somebody said the internal temperature of my potato, and they had a potato like exploding in the microwave. Anyway, there were some funny ones. There were some bad ones too, but I'm going to bring mine up here. And let's see why the potato problem got so much flack and had a national average of one of the lowest ever, 1. All right, so at time t equals 0, they could have done such a great question with this topic. This could have been the internal temperature of a body, and it could have been time of death. That would have been cool. Who does calculus for their potato? Stupid question, right? Same with at the grocery store. You never do calculus for the rate the bananas that are going on the shelf. There hasn't been a food question since because it was so stupid. Anyway, so we've got at time t equals 0, a boiled potato is taken out of the pot and it's left to cool. The internal temperature of that potato at that time is 91 degrees. So I would write that down. It's over here, but I'd write it as I read it, that at that time, that's the internal temperature of the potato, which they're calling T. So that's H of T. So make sure you can understand what the variables are. T is the new X, H is the new Y. All right? So it says that the rate of change of the temperature of the potato, the reason it's negative is because it's cooling. It was taken out of the pot and it's left to cool. It says write an equation for the tangent line to the graph at t equals 0. What do we need for the equation of a tangent line? That should be in your brain like no other. You need 2 things. What are they? Slope and point. Here's my point, and I would even write it down. Point is 0, 91. Make sure you understand this is t, and this is h. All right, what else do I need besides the point? The slope at that point. Okay, so I need dh dt at 0, 91. Here came the first issue. It says it equals negative 1/4 of h minus 27. It's kind of like 1/4 of y minus 20. Do you see how it's a function of the second variable, not the first? So what should we be plugging in for h? 91. What do you think a lot of kids across the world plug in because they're so used to it? Plugging the x one in, right? So that was the first issue. So we have to plug in a 91. We don't have a calculator. This wasn't calculator active. So it was cruel for a couple of reasons. They're messing with the variables on them. It's a stupid question, right? So, and they didn't have a calculator and the numbers aren't particularly great. 91 minus, I haven't done this one since last year, so what's 91 minus 27? 64? Negative 1/4 of that is negative 16. I now have my point. I now have my slope. A lot of kids circle the slope. That'd be great if they asked you for the derivative, but they asked us for the equation of the tangent line. So here's what I would do. I would just do it like we've always done. Y minus the y I know is equal to the slope there, times x minus the x I know. I would write it like that because that's how we've been taught, is we were working with y's and x's. But when you're done, sorry, that should be a negative 16. When you're done, I would replace them. You get full credit for this. But just for understanding the problem, y is my h's. So the temperature of my potato can be determined by negative 16 times the time plus 91. Either of those is acceptable. Am I done with the question? What do you think, Harrison? What does it say to do? Yeah, I'm supposed to use the equation to approximate the internal temperature at time 3. So I need to plug a 3 in. Negative 48 plus 91, what is that? Without a calculator. Negative 48 plus 91. 43. Okay, 43 degrees. Done. You would be over the national average if you could do that. How many points do you think that was worth? 2 or 3? What did I say the average was? Most kids across the world could not even handle the first question, right? And then came the second question. All right. What does that mean? Find the what? Second derivative. I would write it out formally. I would write dH dt down. It was negative 1/4. Can you, oh, you guys, yeah, you have the paper copy.
H minus 27.
H minus 27. I'm going to tell you, I was a reader for this one, so I know this, I graded this problem for 3 days straight, 8 hours a day. So I'm truly telling you what kids did. This was so easy to grade because most of them said it was negative 1/4. You might be like, that's what I would have done. Because it's negative 1/4 H plus, I don't really care, 27/4. Right? I'm going to let you stare at that. And if I actually wrote it out formally, this would be the derivative with respect to t, right, of the first derivative. I want somebody to tell me why. I would say of 20 tests that came across, 19 of them said the derivative of that was negative 1/4. Why isn't it? Are you guys thinking it is too? Well, yeah, watch me put it in context of these variables. Pretend this had been boom, boom, boom. Right? Negative 1/4 times what? dy dx. Negative 1/4 times dH dt. It's the other variable. How mean was that? Right? That's mean of them, but that's why they got slammed for this problem. But yeah, we do negative 1/4 times the derivative of the guts, and it's not dt dt. It's dH dt. Very few kids caught that. So honestly, it didn't hurt your score because you're always compared to the average. So it didn't really matter. But then I'm going to go put up what that was. It's negative 1/4 times negative 1/4 H minus 27. You are right, Kaden. It's negative 1/4 times dH dt. So take a look. It says, does that mean this is an over or an underestimate? That was my tangent line that I used to approximate what is actually happening. But take a look. If the second derivative is this, it'll be positive because the potato's temperature is 91 degrees at time 0. So this is going to be positive. The whole thing's positive. If the second derivative is positive, what does that tell me about the function? It's concave up. Yep. And if we're concave up, our tangent line is going to provide us with a what? Over or underestimate? Underestimate. Exactly. So go ahead and write underestimate. That's a guess, though. You would have to say because the second derivative is positive. Those kids who didn't recognize the variable goofiness here would have said overestimate because they would have had a negative 1/4, so they couldn't get anything. Do you see why they were so pissed at the potato problem? Right? They were really mad at it. And furthermore, their last question, the separation of variables question, was also weird. So it's weird all around. So let's go to part C. It says, an alternate model for the internal temperature of the potato satisfies this differential equation. So now listen, this is a different model for finding the temperature of the potato. G is measured in degrees Celsius, and again, G of 0 equals 91. It says, find an expression for G. When they give you the derivative and they ask you to solve for the top variable, that's what we've been doing for the last 3 days. What's the process called? What's the process called? Separation of variables. Yep. So we're going to say, well, how do I get from GD dt, let's go write it down, back to G. This is separation of variables. It's like dy dx equals negative y minus 27 to the 2/3. All right, so I need to solve this for G. All things G on the left, all things dt on the right. And I'll tell you what my students came back saying, and they were debating about it. They're not supposed to talk about it, but everyone talked about the potato problem. They were so mad about the potato problem. I need to move that over. So I need to divide by it, right? It's just kind of ugly. I need to do 1 over g minus 27 to the 2/3 dg equals, I like to keep that constant or that negative over. They said there wasn't any t. Someone said that yesterday. It was actually Quinn in my other hour. He got to the last problem. He said there's no little t. And I said, well, it doesn't matter because when you integrate, what's the antiderivative of -1? pt. There it is. Negative t. Yeah, so don't let that bug you. It's like the antiderivative of 2 with respect to x is 2x. So this, you're right, Keaton, will be negative t plus some unknown constant. That's the right-hand side. The left-hand side is g minus 27, and I like to see that power to the negative 2/3. All right. How do I integrate that? Power rule, right? How do I use my power rule? They weren't nice on this either. They gave the kids fractions. Wouldn't it have been nice if that was just to the second? But it's not, so we're going to add 1 to the power carefully. That gives us 1/3, right, guys? Divide by that power. How are we doing? What do you think, Alex? Weird, right? But the process is the same regardless of how ugly it is. Isolate the variable. Yeah, I have to divide, and yeah, it's ugly, but I can do that. And then over here, I get negative t plus c. At some point, we need to find c. Who wants to find it now? I do. Okay. I actually do want to find it. What point am I supposed to get? 0, was it 91? Right? So I need to put a 91 in here, either in my head. I'm going to indent when I find it. So I'd have 3. 91 minus 27 is 64 to the 1/3 has to equal negative 0 plus c. You have to know how to do that in your head. What's 64 to the 1/3 power? Also known as the cube root of 64. It should be nice because you don't have a calculator. What's the cube root of 64? 4. That's 3 times 4, technically. So 12 is equal to c. It's still the same process. It's just never monkey see, monkey do. The kids have never seen one like this. Probably never will see it again. The next year it was much easier because this was so disastrous. All right. I've got a negative t plus 12. Who haven't I picked on today? Ava. I just need to solve this for g. What am I going to do first?
Divide by 3.
Yep, let's do that. Divide by 3. Then what, Ava?
And cube root it.
Almost. It is to the 1/3 or a cubed root, so I need to, go ahead, anyone? Cube it, right? So I'll cube it, and then I get g minus 27. Wow, this one's nasty, right? Negative t plus 12 over 3 quantitatively cubed. Wow, 40. Wouldn't you feel like you were doing something wrong? But you didn't. All right? And if you did something wrong, the temperature of the potato was super high. That's why kids were like, I got a temperature of 4,000 degrees. Anyway, so the temperature at any time can be negative t plus 12 all over 3 quantity cubed. Am I done? I don't know. Read the question. Am I done, or do I need to? I think you actually have to find the temperature. Yep, it said find the internal temperature when t, and I forgot to add the 27. When t is equal to 3. So in it goes. Negative 3 plus 12, 9. Divided by 3 is 3. Cubed, 27. Plus another 27. What was the temperature of the potato? 54 degrees. Exactly. That's a nasty problem. All right. We have 15 minutes left, which is perfect, because that's how long it should take you to do your best on the next one, which is really similar. The baby bird. This was an ugly twist on the baby bird problem. So that one I want you to do in class right now. And then there's one more. So 2 FRPs for homework. If you want to work together, work together. It's intended to be, usually we do a ton of group work, but with COVID, we haven't been able to do that, so I don't know how comfortable. I don't like to force groups when I'm not sure how comfortable you guys are with this one. I'm on the road. By now. See if you can pull out a 4 or 5. Yep.
I like flipping that.
You can do whatever you want. Within reason. I don't know. I forgot to stop recording. You're gonna want to log in and listen once this is uploaded.
I'm gonna go just take a